Now we'll take a look at some of the code that illustrates the principles that we were talking about in this unit. This unit has 3 steps associated with it. The first step, step 6, adds the idea of an order to our customer manager system. The second step, step 7, in this unit, deals with the data mapper pattern, and the last step talks about the repository pattern. So now let's take a look at step 6, where in the types assembly we have added an order interface which has 2 items in it, the order ID, a getter, and a getter for the list of items in that order. We have also added to the iCustomer Manager interface a method that associates an order with a particular customer. Inside the customer assembly, we have added a class that implements iOrder called order. It has a constructor that takes the order ID and a list of items for this order, and 2 methods which implement iOrder, the items and the order ID, the getter and the setter associated with them. You'll notice, however, in the interface for iOrder, there's only a getter. So you're only able to get the items and the order ID through the interface. The Customer Manager class now implements the method addOrderForCustomer, taking in interfaces as arguments for the customer and the items, creating a new order, and associating that order with a customer. Finally, in the main program, using the interface iCustomer Manager gotten from Create Customer Manager, you can add an order for the customer. And if you run the program, you see we can find an order associated with a particular customer. Now let's take a look at the data mapper pattern. We are now in step 7 of our application. We have defined a type called iCustomerDataMapper in the types assembly. This interface takes 3 methods: delete, get customers, and save. This interface is implemented in the class CustomerDataMapper, which is found in the Customer Manager assembly. It stores the customers and orders into sorted list. And it implements the methods delete, which it basically looks to see if the customer has an order, and if it has an order, it removes it from the list and then removes the customer. Get customer basically builds a list, and if the IDs are null, then it assumes that it wants each customer that is in the list. Otherwise, it looks for all IDs in the list and returns them in the collection. Save handles both the case where we're creating a customer from scratch or we're updating a new customer. It looks to see if the customer ID that is passed in is found. If it's not found, then we assume we have to create a new customer and then add it to the storage. Otherwise, if we found the customer, we update the order associated with the customer. The Customer Manager has now been updated to use this data mapper. You'll notice the constructor takes an iCustomerDataMapper instance and then saves that instance for use in implementing the functionality associated with the Customer Manager. You notice again, this is an interface passed in using dependency injection. so that the customer manager is not bound to a particular type of data mapper. So in add customer, we use the save method associated with the iCustomer data mapper interface. When we add an order, similarly, we use save. When we remove a customer, we use delete. And when we call get customer, we use the data mapper as well. And that is true whether we get customer by a name or by an ID, or we get all the customers associated. Now you may ask the question, where does the binding between the particular data mapper instance that we're using occur? And that happens in the Customer Manager Factory, because here is where we create the particular data mapper that we're going to use and then pass that in when we create the Customer Manager. By creating the actual customer data mapper instance inside the factory, we are limiting the number of places that know about the actual concrete classes that are used. Thus, we are minimizing the number of places that have to be changed if we have to modify our application. And as far as the main routine is concerned, there is no change whatsoever, and the application runs as it ran before. The Customer Manager repository is found in the Customer Manager assembly. If you look at the constructor for the customer repository, you see that the iCustomer data mapper that it uses is passed in as an interface. The query operation then uses this custom data mapper in implementing the queries. So the query, which is the one method for the repository, takes a criteria class instance which has an operator and an operand. The first thing that the query method does is look and see what the appropriate operator is, whether it's all, ID, or name. And then depending on which operator, it then uses the operand appropriately. For example, if the operator is all, it simply calls the get customers method on the data mapper to get a list of all the customers. If the operator is ID, it then calls the get customers, passing in the ID that is extracted from the operand, and then returns the appropriate list. If the operator is name, it extracts the name out of the operand and then calls the appropriate data manager instance, in this particular case, looping through the customers to find the appropriate one. The customer repository is created in the Customer Manager constructor. Notice how the constructor passes into the customer repository the particular customer data mapper instance that it was told to use. And then within the various get customer or get customers routines, it creates the appropriate criteria and then calls the query method. Now that we have looked at a simple version of the persistence patterns data mapper and repository, we are now ready to look at dependency injection before we introduce SQL Server, web, and web services.